Hello students, welcome back to JJ's physics class. Today we will be discussing about the graphical representation of motion. To describe motion, we can use line graph. Today we will be plotting distance time graph for uniform motion. So what is the speciality of line graph? Line graphs show dependence of one physical quantity such as distance or velocity or speed on another quantity such as time. So therefore, the change in position of an object with time can be represented on the distance time graph adopting a convenient scale of choice. My question here is plot and interpret the distance time graph. So we have time in seconds and distance in meter. 5 seconds the distance covered is 10 meter. 10 seconds distance covered is 20 meter. So it goes on, right? So let us start plotting the graph. First we have to decide the scales, that is what to be taken on the x-axis and what to be taken on the y-axis. So time is an independent quantity but distance depends on time. So independent variable usually plot on the x-axis and distance is taken along the y-axis. So we have the graph sheet here. First we have to choose the x-axis and the y-axis, and we have time in seconds, that is along the x-axis, distance in meter along the y-axis, and first we have to choose the scale. So how do we choose that? As you can see here, time in seconds, it is varies from 5 seconds to 30 seconds. So 5 is the least number and 30 seconds is the maximum number. So our scale should be such a way that it has to fit in this graph sheet. So if you choose 1, 2, 3, 4, we don't have that much space here. So we can choose 5, 10, 15, 20, 25, 30. So that means scale along x-axis is 1 centimeter is 5 seconds. How do we plot that? Starting from origin, 5, 10, 15, 20, 25, 30. That means x-axis 1 centimeter is what? 5 seconds. But what about y-axis? It is from starting from 10 meter to 60 meter. We choose 1 centimeter is 10, 20, 30, 40, 50, 60. So y-axis we take it as 1 centimeter is 10 meter. 10, 20, 30, 40, 50 and 60. Okay. Next we have to start plotting. So how to do the first point here? So we have the time is 5 seconds, distance covered is 10 meter. So what do we do here is from 5 meter, okay, you mark the point from 5 meter and it has to meet the 10 meter distance on the y-axis. So we will take another dotted line where both these quantities will meet. The 5 seconds on the x-axis and 10 meter on the y-axis. There you plot the first point. Similarly, you have 10 seconds but the distance covered is what? 20 meter. X-axis 10 seconds and y-axis is 20 meter. So same, draw two lines where both the two quantities will meet. There you get the second points. Next is 15 seconds and 30 meter. So another point should be here. And next is for 20 seconds 40. So again draw a line to here and line to here. So where you get another point here. And next is for 25 seconds it is 50. Another for 30 seconds it is 60. So you can see that we got all the points here. How do we take the points? As we discussed, on the x-axis 5 seconds and y-axis 10 meter, where they both meet we get first point. Again for x-axis it is 10 seconds, y-axis is 20 meter. Again another point. Again on x-axis 15 seconds and 30 meter. and similar way you plot all other points. Next thing is we are joining all these points like this. So we will get a straight line like this. The nature of distance time graph for uniform motion is always a straight line graph. But what we get from this graph? Let us find out. For that, you need to take a slope. How do we take a slope? You can take any 2 points on this graph to take a slope. Either these 2 points or these 2 points, you can choose your own scale. So what we do, we will draw a triangle from 2 points like this, and we will mark it as A, B and C. What we can interpret from distance time graph, it is the slope. Slope is nothing but AB divided by BC. What is AB here? AB is nothing but, when you look on the y-axis, that is nothing but the distance traveled by the object. And what is BC? BC is nothing but time taken. So slope is nothing but distance traveled divided by time taken. As you can see here, y-axis 1 centimeter is 10 meter. So 10 meter, 20 meter, 30 meter. Or other way you can mark down, draw a line to the y-axis. It meets at 50 here. And draw a line from B to y-axis which meets here. So 50 minus 20 gives what? 30 meter. That is on the y-axis. And how do we calculate the time taken? Again from this point, from B to on the x-axis we get 25 seconds. From C to A we get 10 seconds. So x-axis 1 centimeter is 5 seconds. So 5, 10, 15 seconds. What do you get? 2 meter per second is the answer. That is the slope. Another way of doing this is, again, slope is nothing but AB divided by BC. But what is AB here? We have 3 centimeters here. 1, 2, 3. 3 into, if we multiply by corresponding scale, 1 centimeter we have taken as 10 meter. So 3 into 10 meter divided by, again on the x-axis we have 1, 2, 3. 3 units. 1 centimeter is 5 seconds. So 3 into 5 seconds. What you get again? 30 meter divided by 15 seconds. So we get 2 meter per second. What is that? So slope is nothing but AB by BC. AB is nothing but distance travel divided by the time taken. What is this quantity? We just learned. It is speed. The slope of distance time graph gives speed of an object. The slope of the line is a measure of the speed of an object. Thank you, students.